Welcome to Dunwoody College of Technology, Mechanical Engineering Statics. This is the solution video to Quiz 3 for fall 2019. In this problem, we're given a pipe assembly here. So we have something starting at the origin, coming over on the horizontal plane, then bending in some odd direction here, and then at the end, that tip, we have this applied force acting on it. And that disappeared on me. There you go. There's our applied force. And we're trying to figure out the angle between the pipe segments BA and BC. And so for this problem, we don't actually need this applied force. That's extraneous information here. But we do need to be able to form a position vector from AB and then from BC here. So we're going to start here. Our AB, I think I labeled that backwards. So we're going from A to B. Oh no, excuse me. So I'm going to put these here, tail to tail, these two vectors, tail to tail, and find that angle here between those two. So that's my, so I'm going to make the reverse of what I just said. RBA from point B, to point A will get me that bit, and then from B to C will get me the other vector, and the dot product between them will tell me the angle. So R B to A, I'm at 3 in the x direction when I'm at B, and I need to move back over to A, which is at 0. So let's put in the coordinates of each of these. That's 0, 0, 0. Here we're at 3, 4, 0. And then it looks down here at C, we're at 7, 6, negative 4. So we went a little farther in the x direction, a little farther in the y direction, and then down in the z direction. So starting at B, going to A, we have A position minus B's position. So we get negative 3I, negative 4J, plus 0K. That gets us that bit. RBC. So now we take our C position minus our B position. So we get 4I plus 2J minus 4K. Oh, 4K. So we get 2 points for each of those. Now we're going to do the dot product. RBA dot RBC. And again, that's going to be our I components multiplied by each other. So we get negative 3 times 4 plus negative 4 times 2 plus 0 times negative 4. So carrying that down, we get negative 12 plus negative 8 plus 0. So we get negative 20 as our dot product. We're going to use that. It's going to be equal to RBA, the magnitude, times RBC, the magnitude, cosine of theta. So now we need to go back up here. So our magnitude, RBA, just to save a little room, is going to be the square root of 3 squared, or negative 3 squared, plus negative 4 squared, plus 0 squared. So it's 9 plus 16, 25, square root is 5. RBC, magnitude, it's going to be the square root of 16 plus 4 plus negative 16, negative 4 squared, 16. So you get 16 plus 16 is 32, plus 4 more is 36. So that's going to give us 6. So this equals negative 20 equals 5 times 6 cosine of theta. So rearranging that, theta is our cosine of negative 20 over 30. So theta in that case is 131.8 degrees, or to 3 significant figures, 132 degrees is theta. And that seems to make sense. It doesn't, if we're coming down and over more this direction, it must be beyond 90. That seems to match my intuition. So think we've got the correct answer there.